So in this video we're gonna talk about the plane of symmetry. Plane of symmetry. What do we mean by plane of symmetry? We call it as a POS. This is an element of symmetry. So how do we define the plane of symmetry? Like this, we have this structure. This is a plane which have a symmetry over here. Okay, right? If we put a mirror over here, it will complete its image. Now this is cyclobutane. It is also a plane of symmetry, and it has one more plane of symmetry. This one. Okay. Now we have the cyclic compound, the cycle, sorry, which has infinite plane of symmetry. Okay, there are infinite plane which can pass through the center, which completes its that mirror image, right? Next we have cyclopentane. Cyclopentane, we have one plane of symmetry, right? Could be more than one passing through this, right? Now cyclohexane also could have more than one symmetry, but we are taking one as an example of the plane of symmetry. Now we look at the letter like A. A has plane of symmetry. B also have plane of symmetry. C also have plane of symmetry. D also have plane of symmetry. E also this have plane of symmetry. F doesn't have plane of symmetry. G doesn't have plane of symmetry. H also has plane of symmetry, right? I also have plane of symmetry. O also has plane of symmetry. N doesn't have. K have plane of symmetry. Z have don't have plane of symmetry. U has a plane of symmetry. T also have a plane of symmetry. W also has a plane of symmetry, and Y also has a plane of symmetry. So we have seen the general examples. How do we see the plane of symmetry? Now, when talk about the molecules or the chemistry related problems like molecules. In molecules, how do we define the plane of symmetry? So in molecule, we're going to take the very first example of unsaturated molecules. Unsaturated molecules. We are going to take the example of unsaturated molecules, right? So unsaturated molecule does have plane of symmetry or not? So how do we define unsaturated molecules have plane of symmetry or not? So if we talk about the unsaturated molecules, so first is like we have hydrogen, carbon, then carbon, hydrogen, and hydrogen. Here we have three plane of symmetry. Here we have three plane of symmetry. How? First plane is this, right? Second plane is this, and third plane is a sandwich plane. The plane which contains the molecule, because it is a planar molecule, so it has three plane of symmetry. So in this unsaturated compound, every molecule has minimum one POS, that is also molecular plane. Which is also called as a sandwich plane, right? In second, we have hydrogen, carbon, double bond, carbon, hydrogen, then chlorine. We have over here two POS. One this plane of symmetry, and the by default that molecular plane of symmetry. In this molecule, Br, C double bond, C, H, I, Cl. Here we have only one plane of symmetry. So every that unsaturated compound has at least one plane of symmetry that we have already seen, right? So we're gonna look more examples related to it. Now we're gonna look some more examples. Like we have this compound, hydrogen, it has two plane of symmetry. Here we have This compound also does have one plane of symmetry, right? Because the intersection, that the molecular plane and this plane, here the simple molecular plane, right? Now if we look at this hydrogen and hydrogen, it does this plane and one molecular plane, the two plane of symmetry it does have. Now if we look at this compound, it also have two plane of symmetry, one molecular plane and one the plane passing through this point. And if we look at this compound, it also has three plane of symmetry. If we look at this compound, it does have two plane of symmetry, one this and one this. It does have two plane of symmetry, and this compound has a single plane of symmetry, which is a molecular plane, 1POS. Okay, that was the journal compound. Now we look at the cumene. Allenes. If we talk about allenes, we all know what are allenes, the conjugated double bond, the simultaneous double bond, the are called allene, which we call cumulene, or we call allenes. ALLENS, allenes, right? If we write it properly. This is what? Allenes, right? What is allene? One hydrogen is there. Carbon double bond carbon, carbon double bond carbon, then one hydrogen is there and another hydrogen is there. So it doesn't show GI. Although it is not showing GI right now because it is not satisfying the condition. But C double bond C. Here we have C, here we have D. And here we have A and here we have B. It has plane of symmetry. Here it has, how many plane of symmetry does it has? It has two plane of symmetry. If A equals to B and C equals to D, then it will be having two plane of symmetry. How you can assume that? You can imagine that if the plane passing through A, B and that carbon, that if C and D are same, that is plane of symmetry. If the plane passing through C, this carbon and D carbon, then this molecule will give a plane of symmetry. It has two plane of symmetry if the molecules are same. It has one plane of symmetry if A equals to B and C not equals to D, or if A not equals to B but C equals to D. It has no plane of symmetry if A is not equals to B and C not equals to D. It has no POS. So that was the cumene. Now if you look at the further examples, how do we see the plane of symmetry? Now in case of the cumenes, let's dig into deep of more examples. Like we have hydrogen, carbon, then hydrogen, then chlorine, and here we have also chlorine. How many plane of symmetry it has? Two plane of symmetry. It is the whole molecule is a planar now. Planar molecule. I hope you all understand what do we mean by allenes. This molecules in this plane, then it goes in the perpendicular plane, then it goes in the same plane, then hydrogen, chlorine and hydrogen, chlorine are same plane. That is equivalent to this compound. This is equivalent to this compound. This is equivalent to this compound. So it has two plane of symmetry. If we talk about like more bromine, then carbon, then iodine, double bond carbon, hydrogen and chlorine. So how many plane of symmetry it has? One plane of symmetry. That is a molecular plane. Molecular plane. Now if we look at more, if we look the more compounds, hydrogen, then carbon, then hydrogen, double bond carbon, hydrogen and hydrogen. It has three plane of symmetry, right? I am just writing. I hope all you can understand. Hydrogen, chlorine, and they have zero plane of symmetry because it has perpendicular compound. Perpendicular. Now if I write like hydrogen, carbon, chlorine, double bond carbon, double bond carbon, then this compound, it has 1 POS. If I write more compounds, I usually take a lots of example. Hydrogen, chlorine, it has 1 POS. How many POS does it has? We have chlorine over here, hydrogen over here. It has 1, 2, 3 bonds. It has 2 POS. If we take the examples of this compound, it does have 2 POS. It does have 2 plane of symmetry because it is equivalent to double single bond, and one plane will be passing through the mid center and another plane is the molecular plane, which is called a sandwich plane. If I write more examples like it has 2 plane of symmetry. If we write more examples, it has 2 plane of symmetry. It also have 2 plane of symmetry. It has 2 plane of symmetry. It has 3 plane of symmetry. One this, and one molecular plane. It has 3 plane of symmetry. Now first we looked at, that is the allenes. Now second type of compound we are looking is cyclo compound. The second type of we are looking is cyclo compound. In cyclo compound, we have first unsubstituted. This is unsubstituted cyclic compound. This is unsubstituted. So all these have plane of symmetry here. Second, we are talking about substituted. In substituted, first of all, we're going to talk about the monosubstituted. In monosubstituted, like we have hydrogen, chlorine, and we have this one compound, one plane of symmetry. But if hydrogen and chlorine are interchange, hydrogen, chlorine and hydrogen, then there is no plane of symmetry. Monosubstituted, it is actually disubstituted. When we talk about monosubstituted, in monosubstituted, we're going to take this example later. But in case of monosubstituted, if we talk about how many plane of symmetry does we have, this is the compound of monosubstituted chlorine and hydrogen. We have this plane of symmetry which contain this carbon, chlorine and hydrogen, and passing through the midpoint of this plane, this line, and here hydrogen, bromine, up a line passing through this particular line. Then we have hydrogen and CH3, a plane which is passing through this line. So it has a plane of symmetry. But when we talk about the disubstituted, in disubstituted, how do we see? In disubstituted, hydrogen, chlorine, right? And hydrogen, chlorine and hydrogen. It doesn't have, but it does have plane of symmetry, but it doesn't. Next, the plane of symmetry, if we talk about hydrogen, CH3, then hydrogen and CH3, it does have plane of symmetry. chlorine and hydrogen, hydrogen and chlorine. It also has the plane of symmetry over here. Now if we look the furthermore example, as I take generally a lots of example in my lecture. So if we talk about the next compound, we have hydrogen bromine, then hydrogen chlorine, then hydrogen chlorine, and we have plane of symmetry passing through this line. Then we have hydrogen chlorine, then hydrogen and chlorine, a plane of symmetry passing through this point. Third, we have bromine, iodine, hydrogen chlorine, hydrogen chlorine, then bromine and iodine. There is a plane passing through this line, we have already drawn. Fourth, we have this compound and also a plane of symmetry passing through the midpoint. Fifth, it doesn't have plane of symmetry, don't have plane of symmetry. Sixth, we are all taking the example of disubstituted hydrogen chlorine and hydrogen chlorine. It does also have the plane of symmetry, right? Seventh, hydrogen chlorine and hydrogen chlorine. It also have plane of symmetry passing through this point. And I hope all you are smart enough to understand the examples now. It is a plane of symmetry. Ninth, it has actually benzene has 1, 2, 3, 4, 5, 6 and 1 molecular pair. 7 plane of symmetry benzene has. 10, cis, it has plane of symmetry. 11th, trans, its trans version do not have any plane of symmetry. 12th, hydrogen chlorine, it does have a plane of symmetry. So that's how we define the plane of symmetry in these type of compound. Now we are trying to define the plane of symmetry in the third one, that is saturated compound. Then we're going to look at the multiple phenyl ring. Third, we are going to look at saturated compounds. In saturated compounds like CH4, how many plane of symmetry does CH4 has? 1, 2, 3 and 4 hydrogen. A plane which should contain hydrogen, carbon and hydrogen, and every plane which are going through these points, hydrogen, carbon, hydrogen, will generate a plane of symmetry. How? You can all imagine like a plane containing 1, 2, 3, 4, 5. 1, 2, 3 will also a plane of symmetry. 1, 2, 5, 1, 2, 4, 3, 2, 5, 3, 2, 4. All these have the plane of symmetry, right? So how many plane of symmetry does it? 4 C2 equals to 6. It is actually a little bit easy to understand that every plane which are going to pass through hydrogen, carbon and hydrogen will bisect the space between it and it will be having plane of symmetry. Similarly, these hydrogen passing, the plane passing through these hydrogen and going through the carbon will also generate the plane of symmetry. So that's all. It has 4 plane of symmetry, 4 C2 plane of symmetry. Out of 4 hydrogen, we have to select any 2 that will be a plane of symmetry. Second, we have CH3Cl, CHCl, hydrogen and hydrogen. So 3C1, the plane which must be passing through the chlorine and carbon, which must be passing through another of these 3, one of these 3 hydrogen. So it will be 3C1, that is 3 carbon we have. Similarly, we have CH Cl3, CHCl, Cl and Cl. Again 3C1, 3 plane of symmetry. CH2, Cl2. Cl and Cl. We have 2 plane of symmetry. Cl, we have 2 plane of symmetry. Right. CHClBr2. hydrogen, carbon, chlorine, bromine and bromine. It has one plane of symmetry which is passing through the hydrogen, chlorine and carbon, a plane which is bisect through this bromine interspace. Then CHClBrI. So CHClBrI. It doesn't have any plane of symmetry, so it is called a chiral carbon. This is important. It doesn't have any plane of symmetry, no POS, because you can't find any plane. Okay, so it is a chiral carbon. So whenever we do not have any plane of symmetry, that is called the chiral carbon. Now we're going to talk about the spiro compounds. Spiro compounds, we do have this C, D, A and B. This is similar to this molecules A, B, C and D. If A not equals to B, C not equals to D, then it is 0 POS. If A equals to B and C not equals to D, or C equals to D and A not equals to B, then it is 1 POS. If A equals to B and C equals to D, then it is 2 POS. Then it is 2 POS, right? If we look at this compound, C, D, A and B. If A equals to B equals to C equals to D, then it is POS. How many POS does it have? Because it will be similar to the compound of C, D, A and B. That we all know. The spiro compound are similar to the allene one. So now we're gonna write some more spiro compounds. We're gonna look some more examples related to spiro compounds. Like first, one hydrogen, and we have chlorine and chlorine. It has 2 POS. Second, hydrogen, chlorine, bromine and bromine. It has 1 POS. Third, hydrogen, chlorine, bromine and hydrogen. It has 0 POS. And do not have any plane of symmetry because it has these two compounds are in different plane and Br and H are in different plane. Hydrogen, chlorine, then hydrogen and chlorine. It has 2 POS. Now next, fifth, we have hydrogen, then chlorine and chlorine. It has 2 POS. Sixth, we have two POS. One is passing through this plane and one is passing through this plane. Seventh, we have one POS. Eighth, we have one POS. And as one POS passing through this midpoint and which is going through the middle of the first string. Ninth, 2 POS. 10th, 0 POS. 11th, it has POS, which is the molecular plane. 12th, it also have POS, which is the molecular plane. Now last we're going to talk about the in the POS is multiple phenyl ring. In multiple phenyl ring we also got the POS. In multiple phenyl ring. How in multiple phenyl ring we got the POS? If we have this phenyl ring attached to a single bond, that is a planar. and it does have a POS. But when we attach the bulky groups to the ortho position, this type, then it goes and outside the plane, perpendicular to the plane, that is C and D, and also has the, now if A and B, it is similar to the double bond. If A equals to A not equals to B and C not equals to D, then it has 0 POS. If A equals to B and C not equals to D, then, or A not equals to B and C equals to D, it has 1 POS. Now if you look the triphenyl ring, in triphenyl ring it is similar to the 3 double bonds A, B, C and D. If A equals to B and equals to C equals to D, it has 3 POS. 3 POS. If A not equals to B not equals to C not equals to D, it has 1 POS. Like if you look at the question, first question, chlorine and hydrogen. Hydrogen and chlorine. So it has 0 POS because it is they both are in different plane. So it can't be a plane of symmetry, and since all the 4 substituents are different also, means not same. All the 4 are not same, and neither 2 of them on the same side are same. So I hope you are smart enough to understand, because in 3D it is very good to understand, but in 2D it is a little bit tedious to understand. But once you get, you will be finding it very easy. It is having 1 POS. Third problem. Tertiary butyl group, all we have hydrogen, then aluminium, then bromine. It has 2 POS. Not aluminium, hydrogen. It is a hydrogen. It has 2 POS. And chlorine and chlorine. Wait. This is chlorine, bromine. And this is bromine. Then it has 2 POS. Nitrogen, if I use then it has 1 POS. Now if I use on both sides nitrogen, hydrogen we have over here, we do not need to represent hydrogen, then it is 0 POS. Sixth, if I write hydrogen and chlorine, then it has a 2 POS. One is molecular plane and another is plane passing through midpoint. Seventh, here we have bromine and iodine. Here we have hydrogen and chlorine. It has 1 POS. Now we're going to look at the 8th problem, which is the last of our that so long of plane of symmetry we are doing. That is the more than enough problems we have done till CS3 and D. We have hydrogen and chlorine. So this one, this. So it has 4 equivalent to double bond. So every 2 will change the plane. It has no pairs. All 4 groups are same, are different, but also the plane are also perpendicular to each other. This first plane and this last plane. So that's how we see the plane of symmetry.